Okay, dealing with some nasties in this truck, so we've suited up for this one with the lab coat and the gloves. And we're going to look at the test for alkenes, and in particular we use this test to check for the degree of unsaturation in triglycerides, which is basically, if you remember, triglycerides have this general structure with the three ester groups based on that 1, 2, 3 propantriol, if that would be the alcohol that you would get if you broke that ester apart. These are basically derived generally from plants, but also fish also produce unsaturated fats and oils or triglycerides. And what makes them unsaturated, so what makes them unsaturated is that they basically have carbon-carbon double bonds. So we say they're, if you like, not saturated with hydrogen, because we could actually you would have one less hydrogen because of the carbon double bond on each carbon on end, so 2 less hydrogens in total. So if they were saturated, like the animal-based fats that are solids at room temperature, no double bonds, they would have more hydrogens present. So think about saturated with hydrogen. So these alkenes are what makes it unsaturated. And the way we test for an alkene, so an alkene is a carbon-carbon double bond, is that we add bromine, which is orange in colour, and we will say the bromine will add across the carbon bond. So the bromine, basically one atom each, will add across this double bond. This is where the double bond used to be. We would get bromine add across. These chemicals that form here are colourless. So if we see a colour change from orange to colourless when we add a bromine, that's indicating we have carbon-carbon double bonds. If we don't see that colour change, that's showing that it's a saturated fat or oil. This is a bit similar to what happens when they make margarine. They take vegetable oils which contain alkenes like these, but instead of adding bromine, they add hydrogen. They use a nickel catalyst and moderately high temperatures and pressures to increase the rate. They add hydrogen to some of the alkene groups so that you go from vegetable oil, which has liquid at room temperature, to margarine, which will be a solid just at room temperature. But you know that margarine probably melts at relatively low temperatures. So a little bit of good stuff on solubility in the background of this. So let's get into actually how we do the prac. So firstly, we start off, we need bromine. Now bromine is a non-polar solvent. So bromine contains just 2 bromine atoms, basically separated by a single bond, both elements at the same size, so equal in electronegativity. So this would be quite a non-polar molecule. However, it's also a reasonably reactive molecule for reasons that we don't need to go on here. Bromine, though, is relatively stable when it's stored in water. It's not very soluble in water because bromine is non-polar and water is a polar solvent, but it will dissolve a little bit. So this is our bromine stored in water. But to do this test, we actually need to get the bromine into a non-polar solvent. A, because oil, triglycerides are mostly non-polar, so we'll need a non-polar solvent to have it dissolve in the oil. But we also want to increase the concentration of bromine. We want to get more bromine into the solution so we get a more intense orange colour and we can more easily see it. And to do that, we use a technique called a solvent extraction. So we use a separating funnel. And what we're going to do with this separating funnel is we are going to, let me just grab a funnel. With this separating funnel here, we're going to firstly add a little bit of bromine. The bromine, you know, it attacks the plastics in the lid. That's why they perish quite quickly and become quite hard to undo. We add some bromine. You can see the gas of the bromine falling out there, and it is quite, strictly speaking, should be doing this in the fume hood. The problem is if I do it in the fume hood, it's harder to video, and if I have the fume hood turned on, then you can't hear anything that I'm saying. So we add firstly there, we'll just let that bromine, it's actually the gas is actually flowing down the funnel into there. Probably added a little bit much there. So there's the bromine in the water. Now what I'm going to do is I'm going to add, rest that in there while I do it. I'm going to add some cyclohexane, which is a non-polar solvent. When I add that, so initially this is going to be clear, but when I add it, because bromine is non-polar, it'll prefer to be in the non-polar solvent. So at the moment you can see that top layer already, that's the cyclohexane. A little bit is dissolved already, but not much. When I shake these two, we will see how that top layer becomes much more orange or much redder. That's because the bromine is going from the non-polar water solvent at the bottom to the polar, from the polar water solvent at the bottom to the non-polar cyclohexane at the top. So keep doing that. And we want to get as much of the bromine out of the water as we can and into the cyclohexane. And you can already see that that bottom layer is getting fainter in colour. We won't be able to get rid of all of it, but we can get rid of a fair bit. So now we've done two things. We've got more concentrated here because we had less volume of cyclohexane than water. Now what I'm going to do is just carefully, and this is quite a common technique in industry and making drugs, both legal and illegal drugs. We're going to let the water go out the bottom. Let the water go. And now we just get left with the bromine in the cyclohexane. You can see it's much more red. Now what I can actually do at this point, that will just sit there. I can actually get even more bromine into that cyclohexane. So see the gas pouring out again. I'm going to pour some more. Losing a bit. I want to get that lid on as fast as I can. And then again, oh, that's already closed. What I need to here is put a stopper in the top, getting stuck on my gloves. And then when I do this again, we'll see that bottom layer get lighter again, hopefully. Yeah, and we can even see that more deep orange red in that top layer. So we'll keep going and get as much of that as we can. I won't do another one, that'll be enough. Shake that. Making sure I'm keeping my finger on the stopper. The other way you shake these is to hold it in your hand and hold the stopper firmly in your hand. And there we have our bromine now from our polar water solvent into our non-polar cyclohexane. Again, we'll let that water out. Because if we try and mix the water with the oils, we won't get much happening. Sorry, I let a little bit of cyclohexane through there, you might have seen. So now I've got my concentrated bromine in cyclohexane solution using the polar, non-polar stuff to dissolve that. And then what I'm going to do is firstly, actually I'm just going to pour this down the sink in my fume hood, it's a bit safer. I'll leave that waste beaker in the fume hood just so we don't get as much fumes floating around. So now I'm ready to do this test here, which is a bit obscured by my thing, where I add the bromine to some couple of oils and see whether they are saturated or not. Now you could use this technique to tell how saturated or unsaturated they are. We're not going to do that. It will take a bit longer and need a bit more involved technique than we have here, but if we take here some olive oil, pressed at Tumby Bay Area School, And then to that olive oil, we are going to add some of our bromine solution. Just a few drops. Just going to take the top out so it doesn't suck. And then we just add a little bit. And when we add it, we should see the solution goes, we get that orange colour. Hopefully I haven't added too much. You can see that orange colour that's sitting on top. But then when I stir this in, that orange colour should disappear. So you can see that orange colour has disappeared because, let's make that a little bit out of the way. The bromine has reacted with the carbon-carbon double bonds to form these, we call addition across the carbon-carbon double bond, and it's made that orange colour disappear. Let's just do that once more. We've got a bit of shaking happening, so it's happening quite quick. So yeah, well, you can see that orange is disappearing pretty much straight away. Just put some on the desk. Okay. Now, if we take another type of oil, and for here I've just got some paraffin oil, which you don't need to know about, but paraffin oil is basically a saturated oil. It doesn't contain any carbon-carbon double bonds. And if we take that paraffin oil and we add some bromine, we see we've got that orange colour there again. I'm just clean up that drop that I spilled. But now when we mix that, it just stays orange. So it doesn't get that orange to colourless change like we got with the unsaturated vegetable oil that contained those alkene groups or those carbon-carbon double bonds. So, there you go. There's the orange, and then there's the other one, which kept going colourless. So, that is our test for alkenes, but we've also used that as a little bit of a chance to look again at triglycerides, saturated and unsaturated triglycerides, and also we've been able to cover a little bit on the idea of solubility with things dissolving in polar or non-polar solvents, depending on whether they are polar or non-polar, so likes dissolving likes and that sort of stuff. So, good stuff. Cheers.